Welcome to POEs 1.2.3. This is Introduction to Electricity. If we look at a circuit diagram like this is a 100-watt subwoofer amplifier circuit diagram. This looks complicated, and it is complicated. But today we're going to be talking a lot about what is electricity, how does electricity work, and eventually be able to understand circuit diagrams. So first off, we got to talk about what is electricity. Electricity is just movement of electrons from one place to another. This is going to create an invisible force that provides us with the energy that we use for our lights, our heat, or sound, causing objects to move. So this is very important to understand. Electricity will go through conductors, but not insulators. And conductors are generally going to be metals, silver, copper, gold, aluminum, while insulators are going to be more objects that are non-conductive, like plastics, mica, glass, quartz, air even. So we look here, we can look at the conductors. We got our metal wires and our metal pliers, and we got our plastics we found in our wire wraps, the plastic wrap around the wire, and our insulating handles. Now we got to talk about some concepts of the actual math. Voltage is the unit of volts. So voltage in its unit is volts, symbolized by the letter V. Current is in units of amps, symbolized by the letter A, and resistance is in the units of ohms, and symbolized by the letter omega, and that's that horseshoe here. So current is the flow of electricity. It's measured again in amps. And so if you can think of it as a tank of water is the battery, and the pipe is the wire, the flow through which it goes. So when the faucet switch is off, is there flow? No. When the faucet switch is on, is there flow? Yes. How about when current in a circuit? Well, the current in a circuit is going to be, when it's off, there's no current. Turn it on, there is current. Now, in a conventional scenario, we look at electricity leaving the positive side, going around to the circuit, and coming back into the negative. This was established well before the discovery of what electricity was, and turned out to be incorrect. Actually, electrons travel from the negative side, traveling around, and go to the positive. But because of convention, we've used it so long that in engineering, we use the conventional system, but it shouldn't really matter. Voltage is a big tank that allows the pressure. And it's measured in volts. So if you were to take the pipe off, is there still pressure? Yes, because they're still pushing on the pipes in the tank. So when it's switched on, there's still pressure because it's still flowing through. Same thing with the circuit. If your battery's off, does it still have voltage? Absolutely, because there's still a 9-volt battery. It's not going to suddenly not have any voltage. And you turn it on again, the voltage is still going. It's lighting up the light bulb. Resistance is the object that's going to slow down the current. So this opposes current, and this is measured in ohms, again symbolized by the horseshoe here, the letter omega in the Greek. So if I throw a rock into this little pipe, and it's going to travel down the pipe, get lodged in, what's going to happen to the current or the flow? It will decrease or get smaller. Same thing, if I add a resistor here, what's going to happen? Well, it's going to slow down the current and lessen the brightness of the light bulb. So Ohm's law is the law that we can actually calculate voltage, current, and resistance amongst each other. And so that is found in the equation called Ohm's law. So voltage, abbreviated by V, units volts, and symbolized by V. Current, symbolized by the letter I, units are amps, and its symbol is A. Resistance is R, its units is ohms, and is symbolized by the omega. These are going to be following numbers. These are going to be in your equation. So the equation is V equals IR. Voltage is equal to current times resistance. Now, we can rearrange that, and we can get I is equal to V over R, or R equals V over I. They're just the same one, they're just rearranged differently. Now, I want you to draw this picture. Pause here, Now draw it. Once you're done drawing this, you can actually use this. So if you cover up V, the equation is I times R. If you cover up I, it will be V over R. And if you cover up R, then it's V divided by I. So I want you to do this problem. Okay, we can look at it. Here's the diagram, a 6-volt battery with the 150 ohm resistor and the current traveling through it. So we look at it, we cover up the I that we're looking for, and V divided by R. V6 divided by the 150 ohms is 0.04 amps, or in milliamps is 40 milliamps. Okay, now last one we're going to talk about is electrical power. It is directly related to the amount of current and voltage, and it is equal to power is equal to I, current, times voltage. More current, more power. More volts, more power. And this is measured in units of watts, like the light bulb, 100-watt light bulb. And that's it. If you have any questions, ask your teacher.